trying to find all the angles and side lengths of this triangle. Okay, so here we've been given just the angle, the 90-degree angle here, and the side length here. Well, if we have two angles of a triangle, we can work out the third side because we know these two angles are what we call complementary or add up to 90 degrees. So if we do 90 minus 49 degrees, we end up with that length, the unknown angle here. So 90 minus 49 gives me 41 degrees. That's my unknown angle. So I have, right away, I can figure out the angle, but I'm still missing sides. Okay, I can't use Pythagoras because I only have one side. So I need to be able to describe this shape with a ratio. Okay, so I know what the shape looks like with the angle, so I need to describe the shape with a ratio. So I'm going to just use tan because I like tan. And I'm going to say that since I have the angle, I can go to my calculator and get my calculator to tell me what the ratio is. Because if I have the angle, the tan is input of the angle, and then my calculator's output is going to give me a ratio. Okay, so tan of 49 degrees is going to give me a ratio or slope of 1.1503, so I'm just going to round that to 150. What does that mean then? Well, that means that my slope ratio of opposite of 49 degrees compared to the adjacent of 49, so comparing these two sides, is going to be equivalent to this ratio. Remember that this is a one-number ratio, so it's a ratio to 1. I'm just going to kind of adjust this here, just kind of line it up a little bit better. Okay, so there's my equation that I'm going to solve for. So in this case now, once I have my proportional equation, I can just cross multiply this and solve. So I end up with 6 times 1.150, and I end up with 6.90. I'm just going to round it to 2 decimals to indicate that that's the length of a side. Okay, so now I have solved for the angle. Okay, I solved for the angle. I've solved for the one side length, and I just need to have the third side length, and I have everything down. So this third side length, I have lots of options. So I could use Pythagoras here. So I can say that this is, 6.90 squared plus 6 squared equals y squared. I can also use another ratio. Since we're getting used to doing trig, I'm going to use another ratio here. So I'm going to use the adjacent side and hypotenuse. If I go to my SOHCAHTOA, I know that's a cosine ratio, and I'm going to use 49 degrees. Okay, so the adjacent side to 49 degrees is 6, and the hypotenuse is y. But since I have the angle, I can use my cosine function on my calculator, and knowing the angle, it will convert it to a ratio. And the ratios will allow me to solve for the side length. So the ratio is 0.6560, so I'm just going to round that to 656. So the adjacent side length compared to the hypotenuse, so this side is about 66% of the hypotenuse, and that's about right for 49 degrees. So my calculator is giving me the correct ratio here. So once I have that ratio of adjacent to hypotenuse, I can write it in terms of the side lengths I've been given, so 6 to y. And once I have that, I can cross multiply this, okay, solve it algebraically. We can again use a proportional equation, so if you want, you can say this is times by 0.656, so I can divide going this way by 0.656. Okay, if I solve this algebraically, I'm going to end up with this divide by 0.656 algebraically anyways. Okay, and so the answer I get for y is equal to 9.145, so I'm going to round that to 1.5. So there I have the unknown sides and the unknown two sides and the third angle of that triangle. So I've solved for all the angles and sides. Now it's important to note that if you're off by a little bit, it's close to 6.9, even like 7.1, you just might be off by rounding. Okay, so if this was you calculated like 9.3 or something like that, that's probably the error is probably going to be in your rounding. So we don't worry about that because and when I mark your tests and stuff, I know exactly where the error is, whether it's rounding or it's an incorrect calculation. Okay, so we don't worry about being off by a little bit on the decimal. Okay, so we can solve this other triangle. Now this one's slightly different. Here we had an angle and side given. Here we have two sides given and no angle. Well, if I have two sides given, I can use Pythagoras to find the third side. So the third side here I'll call x. Okay, it's a shorter side, so I'm going to subtract. So it's always the longest side minus one of the shorter sides equals the other side. So the shorter side is got an area of 33 squares, so the side length works out to be plus minus square root 33. And again, we only use the positive version of this because we're talking about length. So this length here is going to be about square root 33, which is a little bit shy of 6. Okay, so it's about 5.9 or somewhere around there. So I have all three sides of the triangle. So I'm almost done here because all I need to do is figure out angle. However, ratio is a different way to describe the shape than angle. And to be able to go from the ratio to the angle, I need to use my calculator. In this case, I just need to make sure I use my calculator in the right direction. I'm going to use the inverse because I'm going from ratio to angle. So here you can use whatever ratio you want because we have all three sides. So we're just going to randomly choose one. So we use, looks like we use cosine and tan over here. So we're just going to use sine. Sine angle A is equal to root 33 over 4, over 7. Okay, opposite of angle A to over the hypotenuse. Now again, this does not solve for angle A, so we need to rewrite it. We need to use the inverse sign. That will give my angle when I know the ratio. So when I work out this angle on my calculator, the angle works out to be square root 33 divided by 7, and then the inverse sign of that. Okay, so I end up with 55.15 degrees. Yeah, that's reasonable. I think the diagram's a little bit off because I think this 4 should be a little bit longer, but 55.15 degrees is my angle A. And I can find the angle in here by using the inverse trig functions, but really the easier way is we know that these two angles add up to 90. So if I subtract from 90, I'll get the complementary angle. So this is 34.85 degrees. Okay, so there it is. I've got all the angles, all the sides. I've solved this triangle.